standard tissue culture and cell culture was two-dimensional. So basically, you'd have the cells in standard medium, and you just plate them out on a petri dish or a glass slide or whatever, and they would be fine in 2 dimensions. But in the body, there are no two-dimensional cells. They're in 3 dimensions. So you might get some cells at the surface which don't have any cells above them, but there are definitely cells below and to the side. So they need a 3-dimensional relationship. So the idea behind this machine was that instead of just printing with medium, we put the cells in a 2-part gel matrix so that then they could be suspended in 3 dimensions. And therefore, that's a more physiological environment. You get a better result. The cells actually do what they're meant to do. The things that we're concentrating on at the moment is the refinement of the cells themselves. So you can't just sling a load of adult cells in and expect them to do the job. So what you have to do is you have to use new young cells. So this is where your embryonic stem cells come in. But we don't want to use embryonic stem cells forever because they've got their own ethical problems. They've got the fact that you're still using cells from someone else. So you've still got organ replacement and tissue problems and rejection. So basically what we're working towards using induced pluripotent stem cells. So we're taking patient-specific cells, creating the structure, and then using that. So in the case of drug testing, it won't just give you an accurate human response. It will give you an accurate patient response. Animal testing is, of course, fundamentally using animals on animal cells. So that will give you a very accurate response of what would happen if you did it to an animal. But if you were to do it on a human, most of the time the result is very different because we diverged genetically from animals a long time ago. So when you come to test it on a human, something completely different happens.
Could this replace animal testing tomorrow?
Not tomorrow, but in quite soon, I think 5 years.